Okay, this video is going to show you how to factorize a quadratic where a is greater than 1. Just before I get started, I want to just check, see who it is that's watching this video. If you're an IGCSE student, fine. If you're an AS student or if you're an A-level student, then it's absolutely vital that you are able to take everything I do here and then do it quicker and more efficiently as time goes on. I'm telling you now that factorizing a quadratic will be in P1, P2, P3, P4, M1, S1, anything else you do from now on, you're going to need to be able to do this quickly and efficiently. So just to say that before we get started, if you're an IGCSE student, yeah, this will be a good bit of revision for your exams. How do we factorize a quadratic where a is greater than 1? Well, what do I mean by that? ax squared plus bx plus c would be the general form of a quadratic there. Quite often we'll have ax squared plus bx plus c equals 0 as a quadratic equation. So we're talking about where a is going to be greater than 1. Well, before I do that, let's just remind ourselves of how we do it if a is equal to 1, such as in the example x squared plus 11x plus 28. And what we're doing is we're looking for two numbers. I use m and n. I don't know what your teacher will have done, but I use m and n, and I say I'm looking for two numbers that multiply together to make that number and that add together to make that number. So they multiply together to make c, 28, and they add together to make b, 11. And then if we're going through it slowly, which I'd say I want you to eventually get to be very quick at this, this is the thing that starts us off. There's only a limited number of possibilities that multiply together to make 28. 1 times 28, 2 times 14. You can see I'm being quite logical in the way that I'm doing this. 3 isn't a factor of 28. 4 times 7, and I would stop there. 4 times 7 satisfies multiplying together to make 28 and adding together to make 11. You should be able to do it in your head. You should be able to do it quickly. And when I find those two numbers, if it's a equals 1, I can just plug the two numbers straight into my factorization there. The factorization of x squared plus 11x plus 28 is either x plus 4x plus 7 or x plus 7x plus 4. It doesn't matter which way round you write that. Okay, that's a equals 1. What about if a isn't equals 1 then? We've got a being 3 here. Well, first of all, because this is a cheeky little one, just check that on all three numbers, all three a, b and c, that there isn't a common factor, which there is here. 3 actually goes into all of those. So before I get started with any complicated method, I'm going to take 3 out as a factor, which leaves me x squared minus 5x plus 6. And now I can factorize x squared minus 5x plus 6. Now, I'll try and do it a little bit quicker here, even though there's a minus in there. I'm looking for two numbers that multiply together to make 6, but that add together to make minus 5. Well, the numbers that multiply together to make 6 we had just a minute ago, 1 and 6 or 2 and 3. But if they've got to add together to make minus 5, it must be minus 1 and minus 6 or minus 2 and minus 3. Well, the only pairing there that add together to make minus 5 as well is minus 2, minus 3. So you're saying 3, and this is the speed really with which we need you working, if not even quicker than that. Two numbers that multiply together to make 6 and add together to make minus 5 are minus 2 and minus 3. This always helps if we're not sure. If there's negatives in there, sometimes it can help for you to just break that down. Okay, what about though if on a more realistic question from the AS level, we're trying to solve those ones, trying to factorize those ones, and there isn't a common factor? Notice what I've done is I've also put equals 0 here. So we're going to be solving this as an equation as well. But let's just concentrate, on factorizing 3x squared plus 14x plus 8. Now, my students call this the AC method because A and C, 3 and 8 in this case, we're going to be using A times C as part of our working out. Let me go through and do it for you. So it starts off looking very similar to how it would for the previous work where a was equal to 1. I'm looking for two numbers that add together. In fact, let's put those the same way around. Let's try and keep consistent. Sorry, that way around. Two numbers that multiply together and add together. Well, when they're adding together to equal the same thing. They're still adding together to equal 14. But when they're multiplying, this is what I said about AC, they're multiplying not to make 8, they're multiplying to make 3 times 8. So same again, I'm looking for M and N here. I'll do it slowly, but I would expect that some of you now would go straight away, oh yeah, I can see what the two numbers are. If you can't, then you're going to say 1 times 24, 2 times 12, well, I'm stopping there, 2 times 12. 2 times 12 are the two numbers, but what we don't do now, we don't put it straight into our answer. What we're actually going to do is replace 14x with the 2 and the 12. So instead of having 14x here, I'm now going to rewrite out 3x squared plus 14x plus 8 as 3x squared plus 12x plus 2x plus 8. The two numbers there have taken the place of 14x in there. Now I could have done 2x plus 12x, or I could have done 12x plus 2x. It does not matter. I'll show you that on a later one, but let's just actually do this one because we're still in the middle of our first example here. So I'm going to say that equals 0, only because we set the equation up to be quadratic equals 0. So let's just summarize. I had that. What I did was factorizing it using the AC method to see that I can split 14x now up into 12x and 2x. Why do I do that then? Because it gives me these two terms here, the first two terms. I'm going to factorize and see what goes into 3x squared and 12x. And 3x goes into both terms. If I take 3x as a factor, that would leave me x plus 4. Once I've done that, I can then look at the second two terms, look at those two now, and say what goes into 2x and 8. And if I take 2 as a factor out, that leaves me x plus 4. Equals 0 only because we're solving the quadratic here. But now I've done my factorizing. The answer's staring us in the face here. I've got 3x plus 2, which will be in one of my brackets, and I've got x plus 4, which will be in the other bracket. We always have to have the same thing there and there, but I'll show you with another example for that. So here we factorized to 3x plus 2, x plus 4. If the question had just said, can we factorize this then, we would have finished it. But because we're solving an equation, and sometimes we solve equations, sometimes we factorize, let's just finish that off. This should be no problem to you at all. If we're doing this, I'm going to get 3x plus 2 equals 0, or x plus 4 equals 0, and get two solutions to a quadratic equation. So I'm not spending any time on this. That works out to be minus 2 over 3, and that works out to be minus 4. You can go back and have another look at that if you need to. Okay, let's go back and carry on with this factorizing business. So this time we're factorizing. I'm not solving an equation. I'm just factorizing this one. Quick check. Is there a number that goes into all three of them? No, there isn't. So I'm going to use my AEC method. What was it? It was two numbers that will multiply together and will add together. They're going to add together to make 7 there, and they're going to multiply together, not to make minus 15, but to make minus 30. So this is one where I would now slow down a little bit. There's lots of possibilities for numbers that multiply together to make minus 30. So let's just really carefully go through them all. So if I pick up the pairings, numbers that multiply together to make 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. But if they're multiplying together to make minus 30, then one of the numbers has got to be a negative to make minus. So it's either that situation, or 1 and minus 30, 2 and minus 15, 3 and minus 10, 5 and minus 6. Now, out of that group of 8 pairs, only one of those, if we add them together, will we get plus 7. Plus 7, it's got to be this one here, isn't it? Where minus 3 plus 10 actually makes plus 7. You will get quicker at that. You will get quicker at that, but if it took us that amount of time, that's fine, as long as we can actually do it efficiently and accurately. So what did we do last time? Last time we said I'm splitting this number up into the two numbers I found. So instead of having 2x squared plus 7x minus 15, I'm going to have 2x squared plus 10x minus 3x minus 15. Now, if I've got that situation there, just like last time, I need to factorize this first part and see what's a common factor. Well, in there, 2x is a factor, which will leave me x plus 5. And then this is more realistic of the sort of thing that we're doing here. Yes, I could factorize and take 3 out, but I know I want to end up with x plus 5 for my next step. I want to have x plus 5 and x plus 5. So here, I've actually got to take minus 3 out as a factor. Still works properly. We're still going to get the correct factorization in there. But by doing that, my next step of seeing that that's one of my brackets, and because x plus 5 is in both of them, has to be in both of them, that's my second one, says I get 2x minus 3, x plus 5 there. Now, just to show you at this stage here, so you do not need to do this, this is extra now, I'm doing it in a different color. At the point where I had this one coming down here, what I could have done was to have said 2x squared, not plus 10x minus 3x, I could have said minus 3x plus 10x minus 15. Okay, so all I've done is I've swapped these two over. I haven't swapped any signs or anything. I've just put the minus 3x in front of the plus 10x. So here it should still work, okay, because it doesn't matter which way around I do it. So if now I'm carrying on down here, the only thing I can factorize and take out of that bit there is x. So that's what I'm going to take out, okay, because I can take x out. If I take x out, it leaves me 2x minus 3. So just like I did with the last one, I've got to have 2x minus 3 in here, guys. So what can I take out that leaves me 2x minus 3? It's what we would have done anyway. We would have taken 5 out as a factor and left us with 2x minus 3. So here, I then have x plus 5, 2x minus 3 as my answer. And we can see that these two are the same. Remember, it does not make any difference if you have a times b or b times a. They are the same answer. Okay, nearly at the end, let's just do one more of these. So again, it's a quadratic equation, so we're going to have a solution. I'd really strongly suggest you try and get ahead of me here. Stop the video and actually have a go at doing this. I'll go through and do it now. Anyway then, so quickly I check, is there a number that goes into all three of those? Absolutely not. 4, 3 and 7 don't have a common factor. So I know it's going to be the AC method. So m times n is going to equal to, and m plus n is going to equal to, m times n is 4 times minus 7, is minus 28. M plus n works out to be equal to minus 3. Yuck. Okay, so that's horrible. So definitely here, you just say, and again, remember what I said to you at the start, it's though that one's the key to doing this. There still is only a limited number of numbers that, or number of factor pairs that are going to work out to be 28. So let's do them. I'll ignore the minus just for a second. So 1 and 28, 2 and 14, 3 doesn't go in, 4 and 7. But now, because it's minus 28, it's got to be minus 1 and that, minus 2 and that, and minus 4 and that, or 1 and minus 28, 2 and minus 14, and 4 and minus 7. And as I say, when you get quick at this, guys, I wouldn't even have written those ones down. In my head, I would have said 1 and 28, no, I can't get to minus 3 from that. 2 and 14, no, I can't get to 3 from that. 4 and 7, oh yeah, 4 and 7, there's a difference of 3. Which way round is it? Is it minus 4 and 7, or is it 4 and minus 7? That would save me some time when I'm going through and doing it. So in order to end up with minus 3, we've got to have minus 7, haven't we? We've got to have the negative number being the larger of the two values. Okay, so that means I'm now going to split minus 3x into minus 4x plus 7x, or into 4x minus 7x. Again, I'll do it both ways, but you only need to do it one way. And it really doesn't matter which way around you do it. Let's stick with the first one that I can see there. So that's 4x squared minus 4x plus 7x minus 7 equals 0. So we're going to be solving an equation. This is an equation rather than just a factorizing. So here I could take 4x out of that. Are you happy that I'm saying that bit there? Okay, I can take 4x out of that. Whoops. Which leaves me x minus 1. So I'd have to get x minus 1 in the second part, but just looking at the second part, I can see that 7 is going to be the factor. Okay, so that's worked out quite nicely there that way around. I think it's easier to do it this way around. Now, having seen it, this gives me 4x plus 7, x minus 1. And remember, equals 0, equals 0. So I get 4x plus 7 equals 0. Or x minus 1 equals 0. I get x equals minus 7 over 4, or x equals 1 there. Now, if at the top stage up there, to change the colour again, if up here I'd said 4x squared and I'd done plus 7x minus 4x minus 7 equals 0, so I'm literally just putting the 7x there and putting the minus 4x there, look, 7x there, minus 4x there, it will still work. In this first part here then, this time I can only take x out as a factor, but that's fine. I can take x out as a factor, which leaves me 4x plus 7. So I think this is just a little bit harder to look and say, in this bit here, I've got to end up with 4x plus 7. So what do I take out as a factor? I take minus 1 out as a factor, and then I get x minus 1. 4x plus 7 equals 0. And I'm not going to do any more from there, because obviously if we were doing the solution of that quadratic, there would be no problem with just getting the answer to that as we go through. So the only other one I will try, just really, really quickly, say that we had something like this. 2x squared plus 3x plus 1. I'm just going to factorize it. If I'm factorizing this one, I would see that m times n and m plus n. So m times n works out to be AC, works out to be 2. M plus n works out to be 3. What two numbers multiply together to make 2 and add together to make 3? It's 2 and 1, isn't it? So we could end up with 2x squared plus 2x plus x plus 1 here doing that. So I'm doing it quite quickly, but I just want to show you a quick step here. That if we actually, with this first half now, take 2x out as a factor there, if we take 2x out, we'll be left with x plus 1. In this second part, when I'm trying to see what's a factor there, the factor is actually 1. So it will be plus 1 lot of x plus 1. You'll see that when you do some of your own ones. So again, this is now going to break down into 2x plus 1, x plus 1, and yeah, we've factorized that nice and neatly. So every now and then, you might need to take 1 out of that second part. Okay, go away and practice lots of these so that you get really good, really quick, and really efficient. It's very, very important. Okay, hopefully all of that makes sense.